The vehicle is a 2001 MAN, part of the L2000 series. I chose it because I had spoken to people who had already converted them, and they assured me that they were a reliable, suitable vehicle for conversion. The vehicle was first registered in 2001, and it's one of the very last of the L2000 series that have absolutely no electronics, no ECU, just a bog standard 4.5 litre turbo diesel engine. When I got the vehicle, it had some very obscure sized and very knobbly military tyres, so I swapped those out for the 22.5 inch Michelins that we've got on there at the moment. I went for 22.5 inches because they're possible to get almost anywhere, as they're the standard truck tyre. Once you decide to build yourself an overland vehicle, I think your primary consideration has got to be what kind of overlanding you're going to do. Right? My kind of overlanding is to get out to out of the way places, but not necessarily places that nobody else can get to. i.e., I want a comfortable vehicle to travel long distances that has a little bit of off-road capability. Now, I could have gone for a Land Rover, a Land Cruiser, something like that, but you end up sleeping in a roof tent and you end up cooking outside, and I'm taking my wife with me and she wouldn't put up with that. So if I went for one of those vehicles, I wouldn't be able to go overlanding. If, like us, you want many of the comforts of home, you've got to go for a truck-based vehicle. I read a very interesting article by a guy called Stephen Stewart. He's very experienced in overlanding, in Land Rovers and a Unimog and trucks. And he suggests, and I must admit I do agree with him, that you're better going for a vehicle that was designed and built for normal road travel, that's been adapted with some off-road capability. So I initially had a good long look at a Unimog, but decided that was too off-road a vehicle, and ended up with the L2000. There were millions of them sold throughout the 80s, 90s and early 2000s for normal road travel, and this particular version has got all of the four-wheel drive capability that I will ever need. When it came to the electrics in the vehicle, I had an MAN with a 24 volt system coming out of the alternator. So I decided to keep things as simple as possible and maintained the 24 volt system throughout the rest of the vehicle. I got my heater, my water pump and my fridge, as many of the appliances that I could find that were 24 volt rated, and for the one or two things like the pizza ignition on the cooker and some of the lighting that needed 12 volts, I've got a little 24 volt to 12 volt dropper, but the basis of the system is 24 volts. Again, keeping it simple, I went for very old-fashioned technology, normal lead acid batteries, normal household solar panels on the roof, just a standard battery charger that you would pick up in any normal truck depot or anything like that. Very simple, very straightforward, but we've spent over 1,000 nights in this vehicle so far. Nothing's let us down. I've hardly ever plugged it in. The fridge has gone virtually the whole time without any trouble. We seem to have a nice simple system that works. I decided to build the cabin box for my overland vehicle at home by myself on my drive. I used composite panels, which are laminated together sections of, in my case, GRP, plywood and insulation. I designed the whole body on SolidWorks, which is a pretty standard CAD/CAM package, and then transferred those files to a panel manufacturer who made up the panels and then cut them out more or less to size, with most of the window and door apertures and roof apertures already cut. So it was basically a case of putting the whole thing together, which I achieved quite easily on my drive at home. The panels arrived, went straight into the garage. Even the big wall panels went straight into the garage. All of my panels had a wooden rebate into the edges, and that formed the bond. Now, I bonded them together with Sikaflex 252. If I was to do the process again, I would forego the wooden edges. I think the rebated wooden edges were there to give me a belt and braces, hoping that I would make the box stronger. But to be honest, I don't think this kind of box and this kind of method of production needs wooden rebates into the end. I think it would save weight, and I think the box would be equally as strong without them. When putting the panels together, I initially fixed the base panel onto the sub-chassis of the truck. This left me with a surface that wasn't level. So I decided to use the base piece of the box as my datum point, and I made triangles in softwood which I knew were 90 degrees in the corner, and used a reference off the floor of the box for every single vertical piece. So I fixed the box together with Sikaflex 252. This is a fantastic adhesive. I did lots of tests beforehand, and invariably once you let it set, you have to destroy the material to pull it apart. It is, however, quite difficult to get out of the tubes. So investment that I made was an electric sealant gun, and that was essential to get all of the Sikaflex out of the tubes quick enough before it starts to take up and starts to skin over. I left all of the form work that I had made to ensure that all angles were 90 degrees in whilst the Sikaflex set, but then it was easy just to take it apart afterwards. Sikaflex 252 is a fantastic adhesive, but you need to maintain a minimum of a 2mm gap between the surfaces that are being bonded. I achieved this by putting pan head screws into the rebates and then Sikaflexed over the top, and when the two panels go together, the screw in the middle ensures that the two panels are not going to go any closer than the thickness of the head of the screw, which is about 2mm. It's essential to have help when you're putting the panels together. It's not the weight of the panel. My son and I could easily pick up a whole side panel, which is 5 meters by 2 meters, near enough. It's twofold. First of all, the big panels, you are very vulnerable to even the slightest breeze when you're trying to get them into position, particularly if you're doing it outside, as I was. Secondly, many hands make it very easy to place the panels in exactly the right position. This means that you're not placing a panel and then moving it, because the Sikaflex adhesive is very, very strongly bonded to the panels, and if you smear it across anywhere where you don't want the panels to be, it's very difficult to clean off afterwards. I fixed all of the internal panel work within the box before fixing on the roof. This gave the additional height to be able to use before placing the roof down and sealing the whole thing together. I placed the roof on top of the constructed box, but didn't allow it to drop down until I'd routed out sections in the side to run wires through for the various different light fittings, etc. around the truck. If I was to do the process again, I wouldn't bother running wires within the edges of any of the panels. I think invariably you have wall cupboards all the way around the truck, and you can easily run a wire channel around the back of the wall cupboards. This makes it easier to make slight modifications afterwards without having to think exactly where you pre-placed the electrical wires. Obviously, if you need a wire into the middle of a panel, you don't have the option, but I wouldn't run wires around the perimeter within any of the panels. Again, I would always leave them inside the vehicle in some kind of trunking. I used Sights windows in my box. That's my biggest regret. Although they're a competent, lightweight caravan type window, I find them not really robust enough for the job. I find the blinds and the fly screens not up to the job. So if I was to do it again, I would choose a more expensive window option. I decided, because they can be vulnerable on the outside to branches going past and they're only made with plastic, I decided to rebate the windows into the panel. So I routed out a section all the way around the window aperture and then put in a recessed aluminium frame into which I clamped the Sights windows. I think this has been a fantastic thing to have done on the truck, as it does protect the windows from the scraping effect of branches when you go past. Unfortunately, the plastic still scratches, but it doesn't take the brunt of the scraping of branches when you're going through countryside terrain. When you are putting together a cabin or box for your vehicle, you cannot use enough masking tape. The Sikaflex adhesive sticks to anything, and it's much easier to peel masking tape smeared in Sikaflex adhesive than it is to clean Sikaflex adhesive off the panels. So whenever you're fitting doors, windows, anything, use a good quality masking tape. Once I decided to build my own overland vehicle, I had to decide what sort of system to use to prevent the transfer of the torsions within the chassis when going over rough ground, transferring up into the body. Now, there are multi-point systems where 3 or 4 points are in contact with the chassis, and there are some of them that are mobile. And then there is a rail-on-rail system that's fixed at either the front or the rear of the vehicle, and that uses springs along the rest of it to allow for the torsion. It's called a torsion frame. I decided to go for the rail-on-rail method. I went to Bad Kissingen in Germany and spoke to an awful lot of people, had a look at an awful lot of vehicles, crawled around underneath quite a number of them and tried to figure out which I felt was the best, and also which was most suitable for the type of travel that I'm going to be using. So my chassis is fixed at the back, and then along its length there are sets of springs which allow the sub-chassis, which holds the cabin, to separate from the chassis of the MAN vehicle. I designed the chassis in SolidWorks. I used the technical elements of the software to try to determine the thicknesses of the metal and how stiff the chassis had to be. I'm now convinced that it was vast overkill. I feel the chassis is both too strong and heavier than it might have been, but now I know how strong the cabins are, and did some tests on separation of the sub-chassis from the chassis, and I've seen how much you can allow the chassis to articulate, so thus preventing the stresses and strains coming through into the cabin above. I had the chassis to my design built by an engineering company in Bolton. Once the two chassis were bolted together, as I said, fixed at the rear, before I put the springs on, I articulated the chassis of the vehicle to its furthest extent by hooking each of the back wheels up to a crane. I then measured the separation all the way along the chassis at each spring mounting and noted down how far apart the maximum was that they were able to get to. I then put the sets of springs in and tightened them up so that the springs bottomed out before the maximum allowance of movement of the two chassis. Hopefully this has allowed something close to the maximum amount that the torsion chassis will flex, while still anchoring the chassis between the subframe and the frame on top. I did a lot of test fitting. I test fitted the rear wheel carrier. I test fitted the bike carrier, put the bikes on. I decided to put the bike carrier above the spare wheel so that they would be quite high and out of harm's way and out of being the way of being stolen. Unfortunately, I ended up having to modify this because they were high, and they were so high that I was risking life and limb every time I brought them down. So you will see further on that I had to bring the bikes down and put them inside a box so that they are now secure, but they're low enough to get easy access to. The chassis was built. I sent it away to be galvanised. I think that the galvanising process on the sub chassis is a very good process to use, as once the chassis is on the vehicle and underneath the cabin, it does get a lot of weather and a lot of road dirt onto there. So I'm sure the galvanisation process helps to prevent any corrosion. So if we wander into the truck, up the steps, there were quite a few things that were specifically wanted in our vehicle. We wanted a nice big entrance between the cab and the cabin, because my wife likes to trip in and out easily between the two, and we're not getting any younger, so we decided to extend the top of the cab so that we could make that crawl through into a walk through. I wanted to get a fridge that was not down at floor level. In all the previous motorhomes I've had, the fridge has been way down at the floor. It's much easier to be able to get into and out of the fridge when it's up at this level. When we first went away, me, being a man, completely forgot to put a mirror anywhere in the van. So the first place we had to go to was a DIY store and buy a mirror so that the wife could do her hair. Kitchen area. I wanted a complete full-sized cooker. So we've got a full 4-burner hob, run off the gas tank underneath. We've got a separate grill and a separate oven. We had a similar sort of unit in our last camper van and thought it was fantastic. Decent sized sink, and drawers pulling out for cutlery storage. Nice drawer for all the pots, pans and everything. You don't need too many when you're out. You don't need too much stuff. A set of pans, a set of plates, some cups and glasses. That's it really. You don't need lots. One thing I have changed, I had a cupboard for the food and it was a pain to get to the back of. So now we've got a nice big drawer, storage for food down in here, storage for bottles at the back, and the whole unit pulls right out from the back to give us access in there and easily get whatever we need. There's a little storage unit underneath the cooker, and there's a lift up flap here to extend the worktop area. across the door, which is absolutely lovely for cutting your salad, looking out. Another prerequisite was a fixed bed. So we've got a fixed bed over there at the back. On our last motorhome we had to make the bed every night, and a fixed bed was an absolute necessity. Somewhere nice to sit, somewhere comfortable. It's not always sun shining when you're overlanding, and I've seen a lot of overlanders with very, very small windows. We liked the big windows, so we put a big window in there. What I really, really like is that fixed table. It's just a tiny little table, completely fixed, there all the time. Handy for a brew, handy if you're having a little sandwich. If we want a full meal, we have a table stored behind the fridge that fits onto that rail and pulls out across this area here. Plenty USBs. You can never have too many USBs, and there's the heater outlets there. So if we come round further, another absolute necessity was a full wet room. So we have a full wet room in here, got a mirror, tile floor, and we can have a nice shower in there. We carry quite a bit of hot water. I put in a cassette toilet, but if I have a look, that's where the cassette toilet used to be. I found it difficult in some areas sorting out the cassette, so I'm having a look at another toilet option. Perhaps I might discuss that a little bit later on. And then we whiz ourselves around, close the wet room, and we're back to the cab. So all in all, we find it a very comfortable area. Nice sitting, stretching out area, nice fixed bed, and a good sized kitchen. I am no expert on electrical systems, but I just like to give you a brief overview of the very simple system in my truck. If we start at the left hand side, there is a standard 24 volt C-Tech charger that you can pick up in any truck depot. That's connected to the truck batteries and we'll charge them up if ever we plug in. Underneath that, the little box is a Sirix controller that basically has a look at the two banks of batteries and decides whereabouts the charge that's coming in from either the vehicle batteries or the solar panels is going to go. Next to that, my Sterling inverter. Coming further right, I've got two banks of fuses, the top one 12 volt, the bottom one 24 volt, and very, very simple system of one fuse per item. So the electrical wire comes in, goes through the fuse, usually up to a switch, to the appliance, and then back to the batteries. To the right of that is the electrical consumer unit for if we plug in, and the grey appliance with the ribs on is the solar charge controller. So it's very, very simple, very, very straightforward. Originally, the bikes were stacked onto a bike rack just on the back of the truck. When we went to Morocco, I found that the sand got into all the bits of the bikes and we ended up ruining them. So we built, or had built, I had built a bike box. Inside the bike box, we have two very well protected mountain bikes. I take ladders, deck chairs and things like that. Also, I have storage for the ladder on the vehicle in the bike box as well. So everything's secure and locked away. Protects the bikes, keeps everything safe. So, what have I learned from going through the process of designing, having built, and then using the sub chassis on the particular vehicle that I've got. First of all, I think the chassis that I produced was complete overkill. I think it was much heavier duty than it needed to be, and I think that most of the chassis that you see on overland vehicles are much heavier duty and much heavier than they actually need to be. The bikes, I put the bikes out of harm's way and out of way of being stolen, but I didn't think through how often we need to access the bikes, so I've ended up bringing the bikes down. Integrating the spare wheel into the torsion chassis, I think, was a good idea. It's easily accessible on the outside of the vehicle, it's quite secure, and I'm quite happy with that.